Hi, today we're going to do section 3.2, and 3.2 is very theorem heavy. And it looks like I have a lot of words on the screen. Right now I do, but moving forward, I'll be able to simplify this for you a little bit further. So last time we started taking a look at what happens when you have two lines cut by a transversal. You get a different set of angles. You have your corresponding angles, your alternate interior angles, your alternate exterior angles, and your consecutive interior angles. And while that's all fine and dandy, what we're really interested in is when we have two parallel lines. So like these two lines right here are going to be parallel, and they are cut with a transversal. And so we have our angles here. We got angles 1, 2, 3, 4, 5, 6, 7, and 8. And if you look at these angles and study them hardly, you can start to see angles that are congruent. And that's what a lot of today's section and next time section 3.3 is going to be about. So we're going to start with the corresponding angle theorem. And I have this written out because it's a lot of writing and I want to be able to streamline this information for you. And so the corresponding angle theorem states the following. If two parallel lines, so that's like this line, we'll name these lines L and M. If we take lines L and M and then cut them with transversal T, then the corresponding angles are congruent. So those corresponding angles would be like 2 and 6, 1 and 5, 3 and 7, and 4 and 8. Next is the alternate interior angle theorem. And same sort of thing, if we have two parallel lines and we cut them by a transversal, then the alternate interior angles are congruent. So 3 and 6 and 4 and 5 are congruent. Next, I'll scroll back up to the picture after I read it, is the alternate exterior angle. Once again, if you have two parallel lines, cut them with a transversal, then the alternate exterior angles are congruent. So that's going to be like 1 and 8 and 2 and 7. Finally, we're going to change things up just a smidge, is the consecutive interior angle theorem. And that states if two parallel lines are cut by a transversal, then the consecutive interior angles are supplements. That's a little bit different. So 3 and 5, if we add them together, is going to be 180 degrees. 4 and 6, if we add them together, is going to be 180 degrees. Here's what this all, sums up to. If we take two parallel lines and we cut them with a transversal, and I'm going to go ahead and put an A everywhere we see an acute angle. And I'm going to put an O everywhere we see an obtuse angle. So that's an obtuse angle, that's an obtuse angle, that's an obtuse angle, and that is an obtuse angle. Next, let's put a where the acute angles are. So we got A there, A there, A there, and A there. So we have our acute angles and we have our obtuse angles. Here's what you need to know. All the obtuse angles, so all the O's, they're going to be congruent. And all of the acute angles are A. They're also going to be congruent. And if you take one of those acute angles and add it to the obtuse angle, it is going to equal 180 degrees. But be in mind, this only applies if these two lines are parallel. If those two lines are not parallel, then none of this holds true. So if those two lines are parallel, then that information I just gave you is true. So with that being said, if I'd go ahead and draw, same sort of setup here. And I label our angle right here as 120 degrees. And I then go ahead and list out angle 2, 3, 4, 5, 6, 7, and 8. And I want to identify every single angle that is 120 degrees all we need to do is find the other obtuse angles. So that's going to be this vertical angle right there, this corresponding angle right there, and this alternate interior angle right there, if we're going based off 4 anyways. And so angles 4, angle 5, and angle 8 all measure to 120 degrees. All right, let's go ahead and step things up by just 1 notch. Do a little bit of algebra, because algebra is our friend, and although geometry might be just 1 year, algebra is forever. So we have the same sort of setup here. This angle right here is going to be 115 degrees, and this acute angle is going to be x plus 5 degrees. And then we're going to have this angle right here, which is the angle of measure, or angle 4. And so we know that the measure of angle 4 is going to be equal to 115 degrees. So that's going to be right there. And then we know that these two consecutive interior angles, one's obtuse, one's acute, they're going to add up to 180 degrees. So we're going to take the measure of angle 4, add to it our x plus 5, and that's going to be equal to 180 degrees. Well, we know that the measure of angle 4 right there is 115 degrees, so we have 115 plus x plus 5 is equal to 180, or x plus 120 is equal to 180 degrees. If we subtract 120 from both sides, we will get x is equal to 60 degrees. If we want to do another very similar scenario about finding the value of x, we can go ahead and do that right quick. Let's go ahead and draw these just a little bit closer together for example's sake. That will turn into a line. There we go. And so if this angle right here is 136 degrees, and this angle down here is 7x plus 9 degrees, and then we have angle 1 here in the corner, I want to find the value of x. Well, we know that the measure of angle 1 plus the right next to it, 136 degrees, is going to equal 180 degrees, because it's a straight line. So if we subtract 136 from both sides, we get that the measure of angle 1 is going to be equal to 44 degrees. We also know that the measure of angle 1 is going to be equal to 7x plus 9 degrees. They're alternate exterior angles, so they are congruent. We'll put that right there, alternate exterior angles. So we can set these two equal to each other, so 44 is equal to 7x plus 9. If we subtract 9 from both sides, we're going to get 35 is equal to 7x, or x is equal to 5 if you divide 7 on both sides. Finally, we're going to do a little proof, and I want to prove that when you cut two parallel lines by a transversal, that the alternate interior angles are congruent. And so if you're given two parallel lines, and we cut them by a transversal, T, and so we're going to have line P right here, line Q right here, and P and Q are going to be parallel. And all we need is angles 1, 2, and 3. So we know that P is going to be parallel to Q. That is given. We know that angles 1 and 3 are going to be congruent because those are corresponding angles. We also know that angles 2 and 3 are going to be congruent. Oops. I just need to redraw all of that. And that's because those are vertical angles. So by the transitive property, if 1 is parallel to 3, or sorry, congruent to 3, and 2 is congruent to 3, then 1 must be congruent to 2. And those angles 1 and 2 are alternate interior angles. They are congruent, so that is transitive property proving that. All right, that's all I have for you today. I'll see you in the next one.